Hey guys, today we're gonna present about trigonometry in navigation and surveying. Myself, LINGGES SUNDRAKANAPAHTI. My metric number is 01DKA21F 2036.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURLYANA BINTI Kamaluddin. My registration number is 01DKA21F 2039.
Assalamualaikum and hello everyone. My name is ROZANA binti ZABRI. My matric number 01DKA21F2057.
My name is LEONG. My number matrix is 01DKA21F2048.
What is trigonometry? Trigonometry is the field of mathematics that analyzes the ratio between triangles, angles, and lengths. In its concept have assisted ancient explorers in tracking the stars and navigating the oceans, and real-life application of trigonometry are now found everywhere. It is also used for ancient land and sea navigators. It is started with the most basic navigation equation, for example, speed times by time equal to distance.
Trigonometry in navigation. Navigation is the process to accurately determine one's position and planning a route for the movement of a craft or vehicle from one place to another. Navigation also refers to the specialized knowledge used by navigators to perform navigational tasks. Navigational techniques involve locating position compared to known location and patterns, as well as determining the distance between places. Modern navigation relies on satellites to determine position and to travel by sea and by air. Trigonometry is fundamental to navigation. Trigonometry is used extensively in calculation referring to Cartesian coordinates. Cartesian coordinates are used to represent north, south, east, and west direction. Through the use of trigonometry, the distance between objects, the required direction, and a vessel or aircraft bearing can be calculated.
Navigation is a field of study that focuses on monitoring the movement of vehicles from one location to another. The term bearing is used when dealing with navigation and may take one varying definitions depending upon its context. The US Army defines the bearing from point A to point B as the angle between a north or a south ray with origin at A and the ray starting at A and containing point B. A bearing consists of two characters and one number, such as and 48 degrees E, which means north 48 degrees east. This is a very popular method of determining position. It is easily understood. Three additional examples are given below. Airplane pilots define bearing as an angle measured clockwise from north. For example, east is 90 degrees, south is 180 degrees, southwest is 225 degrees, and so on. The diagram at the right shows an airplane flying at a bearing of 135 degrees. When a problem involves the word bearing, the manner in which the angle is presented will tell you which of these methods is being used. Both methods may appear in problems relating to the law of sines or the law of cosines.
Example 1. A hiker starts at point A and travels in a direction s 42 degree W to point B, then s 35 degree E to point C, which is directly south of A, and finally returns 5 miles directly to point A. Find the total distance hike to the nearest tenth of a mile. Okay, the solution is, since the both represent a north-south directions, alternate the interior angles DBC and BCA are congruent. M of ABC equals to 103 degree. Since we are dealing with two angles and two sides, the law of sines will be applied. Okay, firstly, what we need to do is, since 42 degree over A equals sin 35 degree over C equal to sin 103 degree over 5. And then the next step is C in a bracket sin 103 degree equals to 5 in a bracket sin 35 degree. And then we will get C equals to 2.694. Okay, and the next step is A in a bracket sin 103 degree equal to 5 in a bracket sin 42 degree. A equal to 3.43. Okay, and then we need to sum up. For the last one, we must sum up C, A, and 5, which is 2.94 plus 3.43 and plus 5 equals to 11.37. And then we need to convert to miles, which is the last one answer is 11.4 miles.
Okay, this is navigation words problem. For example, a ship proceeds on the course of 300 degree for 2 hours at a speed of 50 knots. 1 knot equal 1 nautical mile per hour. Then its change course to 230 degree could continue at 50 knots for 3 more hours. At that time, how far is the ship from its starting point? Okay, first step, we must make a diagram. So let me draw that diagram first. Okay, this point A, and then this one B, this one is C. Okay, B is 30. How we make a 30? 50 times 2, so we get 30. Okay, point C, 55, we get from 50 times 3, so the answer is 45. So how to get x? So we use cosine rule. Okay, this is a cosine rule. Okay, so step A square equal B square plus C equal minus 2BC cosine A. X square equal 30 square plus 45 square minus 2 times 30 times 45 cos 110 degree. X square equal 3848. X equal square root 3 X equal square root 3848 equal 6. This is the answer for X. Okay.
For example, very often a plot of land is taxed according to its area. Sketch the plot of land described, then find its area. From a granite post proceeds 195 feet east along Tasker Hill Road, then along a bearing of of south 32 degree east for 260 feet, then along a bearing of south 68 degree west for 385 feet, and finally along a line back to the granite post. As you can see the diagram, from the bearing given, we deduce that angle PQR is equal to 90 degree plus 32 degree, and the answer is 122 degree. The angle of QRS is equal to 180 degree minus 32 degree plus 68 degree is equal to 80 degree. To find the area of PQRS, we divide the quadrilateral into two triangles by introducing PR. Area of triangle PQR is equal to 1 over 2 times PQ times QR sine Q. So the answer will be the area of triangle PQR is equal to 1 over 2 times 195 feet times 260 feet sine 122 degree. The answer is 2,001,500 feet.
So, what we learned today is trigonometry is used to set directions such as the north, south, east and the west. It tells you what direction to take with the compass to get on a straight direction. It is used in navigation in order to pinpoint a location, and it is also used to find the distance of the shore from a point in the sea.
Question 1. What is your overview on trigonometry? Overview: trigonometry in the form of triangulation is at the heart of navigation, whether it's by land, sea or air. GPS system use triangulation to find and fit position. Triangulation is also used to measure the distance between Earth and distant stars and galaxies, thus aiding future space travel. Okay, in this slide, you can see example trigonometry on navigation. First, trigonometry on land. Second, navigation by sea. Third, GPS navigation. And last, trigonometry and surveying. So next question.
Why is trigonometry important to navigation? Trigonometry is used in navigating direction. It is estimate in what direction to place the compass to get a straight direction. With the help of a compass and trigonometric functions in navigation, it will be easy to pinpoint a location and also to find distance as well to see the horizon.